The interstellar wanderer has returned brighter and clearer than ever before. Far beyond the familiar boundary of the solar system, where sunlight fades into near silence, a new visitor has been captured in unprecedented detail. The James Webb Space Telescope has once again turned its golden eye toward the deep unknown, and what it has revealed is reshaping how humanity views objects between the stars. For the first time, astronomers have obtained a sharp, high-resolution image of an interstellar object known as 3I, Atlas, a rare traveler passing through our cosmic neighborhood. It is only the third confirmed interstellar object ever detected, following Oumuamua and 2I, Borisov. But unlike its predecessors, this one has been observed with extraordinary clarity. This is not a faint streak of data or a blurry point of light. It is a structured, detailed worldlet, an ancient fragment of another solar system revealed in full definition. For scientists, this moment feels like a bridge between worlds. We are no longer simply detecting a passing object. We are directly observing a physical piece of another star system drifting through our own. The image shows an irregular, elongated body wrapped in a faint, glowing halo of reflected light, like a whisper of its long journey through interstellar darkness. Around it lies a thin veil of dust and vapor, slowly dispersing into space, marking its passage like a fading trail. Webb's infrared instruments revealed a surface far more complex than expected. Instead of being smooth or uniform, the object is scarred with ridges, fractures, and uneven textures. Every mark appears to be the result of ancient impacts, thermal stress, and long exposure to cosmic radiation. This is not a pristine rock. It is a survivor. Spectral analysis deepened the mystery further. The object contains frozen carbon compounds, silicates, and complex organic molecules, materials considered essential precursors to planetary chemistry and potentially even life. This discovery suggests something profound. The raw ingredients of life are not unique to our solar system. They are scattered across the galaxy, carried silently on interstellar wanderers like this one. When the first processed image reached mission control, a rare silence fell over the room. Scientists were not just looking at data, they were looking at matter formed under another sun, now passing through our own system like a drifting relic from a forgotten world. 3I, Atlas has likely traveled for millions, perhaps billions of years. Along its journey, it has crossed interstellar clouds, endured radiation storms, and survived gravitational disturbances that may have ejected it from its original home system. Subtle heat signatures beneath its icy exterior suggest it is not entirely inert. Internal decay processes or slow rotational heating may still be releasing energy. This means it is not simply a dead fragment, it is an active remnant of another planetary system, still evolving in its own quiet way. Originally detected by wide-field sky surveys designed to identify near-Earth objects, its hyperbolic trajectory quickly revealed its interstellar origin. It was not bound to the Sun. It was passing through, just once, on an endless journey across the galaxy. Ground-based telescopes first traced its motion and brightness, but could not resolve its structure. Only space-based infrared observation made it possible to see its true form. And what Webb revealed surprised everyone. The chemical fingerprint suggests formation in a very different environment than our own, possibly around a cool red dwarf star. This implies a system with lower energy output, different radiation conditions, and potentially a very different pathway of planetary formation. In other words, we are not just seeing a rock. We are seeing the architecture of another solar system, preserved in frozen form. Its reddish coloration is caused by radiation-processed organic compounds known as tholins. These complex molecules are especially interesting because they are also found in the outer regions of our own solar system, particularly on comets and icy bodies. They are widely considered chemical precursors to life. This raises an extraordinary possibility. the chemistry of life may not be isolated to Earth-like worlds. It may be distributed across the galaxy, embedded in objects that travel between stars. The object itself is loosely bound, more a rubble pile than a solid body. Gravity and frozen volatiles hold it together weakly, while slow tumbling motion indicates structural fragility shaped by eons of collisions and thermal stress. Occasionally, Webb detected faint jets of vapor erupting from its sunlit surface. As it approaches warmer regions of space, trapped ices sublimate, releasing gas and dust into a temporary coma-like envelope. This creates a faint, glowing halo, an ethereal signature of activity that defies expectations for such a distant and ancient object. Scientists were particularly struck by this continued activity. Even after millions of years in deep space, it still responds to sunlight. It still changes. It still breathes in a cosmic sense. This suggests that interstellar objects may not be inert debris, but dynamic carriers of material and chemistry across the galaxy. Some researchers now propose a radical idea. Every star system may eject countless such fragments. Over time, these wanderers may seed interstellar space with dust, ice, and organic molecules, slowly mixing the ingredients of planetary systems across vast distances. If true, then the galaxy is not a collection of isolated systems, it is a connected chemical network. A slow exchange of matter between stars. A cosmic circulation of material that links distant worlds across time. 3I, Atlas may once have belonged to a planet that was shattered or ejected during the chaotic early formation of its system. Now it moves alone through the void, carrying the memory of its origin in every atom of its structure. And yet, despite its isolation, it is not truly separate from us. Through Webb's mirrors, its ancient light is finally being translated into human understanding. Every photon captured by the telescope has traveled for years beyond counting, bouncing off alien ice and rock, crossing interstellar space, and finally landing in a machine built by human intelligence. It is, in a sense, a meeting across civilizations. Not between beings but between histories, one natural, one technological. This observation is more than a scientific milestone. It is a reminder of how far human vision has extended. From ancient sky watchers tracing patterns with the naked eye, to a telescope stationed far beyond Earth, now capable of imaging visitors from other stars. And even as 3I, Atlas continues its journey outward, fading slowly into darkness, its image remains. A symbol of connection. A fragment of another world briefly made visible. A reminder that space is not empty, it is full of travelers, stories, and ancient paths crossing without ever touching. Because between the stars, nothing is truly isolated. Every object carries history. Every fragment carries origin. And every encounter reveals a deeper truth. We are part of the same vast, moving system. We are not observers standing outside the universe. We are participants inside its endless journey. And somewhere far beyond the reach of any telescope, other worlds may be looking into their own skies, wondering the same thing we now wonder in return.